actually going to cheat and cover loops today. Loops will not be on the midterm. But scheduling got messed up. I'll cover it. The assignment is due after the midterm, not this Sunday. Assignment's due next Sunday, and they will not be on the midterm. We are recording, right? Yeah. But still, we'll cover them.
So I have a stupid question for you.
Yes.
As far as computer science versus software engineering degrees here, what do you think would be more versatile? I know there's a lot of overlap between the two. So I've looked at a lot of software engineering jobs, and they all say computer science degree or related.
There is a lot of overlap. I am not an unbiased party, don't listen to me. But with that caveat, bad advice is freely given. If you are not coming from a CS degree, study CS. If you already have a CS degree as an undergrad or something like that, then software engineering is probably a great thing to do. It's going to be really hard to be a really good software engineer without having the CS background, in a way. Software engineering tends to be delayed effect. So if you study computer science or something like that, work for 5 years, and start to think that your boss is an idiot, that's a great time to go study software engineering to become a boss who is not an idiot. But that's how I see it. But I'm a programmer first. I'm co-author of a book of software engineering, but I still see it as it's all about programming.
So would you recommend doing like the interdisciplinary track for CS with the software engineering?
I would definitely recommend whichever one you do to take as much you can of the other stuff.
Okay.
But if you don't have a CS background or a CSE background, I would recommend do the MSCS first. You can always come back later. You can always come back in 5 years. Sure. By the way, right?
Job security, all right?
Yeah, for me, no. You laugh, but don't laugh. You may not do it. You may not do it officially by going to a university or something like that, but you should be learning all the time, right? Don't think that you're gonna stop learning when you go out, because if you do, you're gonna suck in 5 years. So you need to keep learning all the time. Learning may not necessarily mean going to a university, but. And by the way, I hope KSU does the same thing. After you're one of us, I know that SPSU did the same thing. I still think of this as SPSU. It's a lot easier to come and take one course after you have been our student, right? So if you feel that 5 years from now we are offering a really cool class in something that interests you, that right, you want to do big data and we are offering a big data class or something like that, it is relatively easy to come as a post-bac student and just take that class. You still pay, but when you think about it in terms of that kind of stuff, you pay maybe $1,500 for a class, which is super cheap compared to technical training or something like that. So it's one of the options. It's not. There's many, many other ways of learning. You don't have to come to a classroom to do that. But keep in mind that it is an option forever. Cool.
It seems like computer science would be more versatile, and whereas is it more to have software engineering?
It's more the first jobs that you're gonna get are gonna be computer science, right? Software engineering tends to make a lot of sense when you have a big team and you're trying to coordinate that stuff, and nobody's gonna let you coordinate anything until you have shown that you can program, right? So getting to that you can coordinate stuff stage without going through programming is gonna suck. And if you're gonna get a software engineering degree and then go work as a programmer anyway, you might as well get a CS one. But yeah, always computer science. But I'm a CS guy, right? I mean, that's like for me, it's all about programming. And I don't even know all the wise people in software engineering have retired. Dr. Sway and Dr. Duggins were amazingly wise in software engineering, but they have both retired. So now I don't know who in software engineering are wise. Actually, oh, but he's not doing software engineering, yeah. Yeah, and we kicked, yeah. The other guy left. Larty was really good too, but he left. Because what you should do if you are still deciding is go talk to somebody from software engineering to have them sell you into that.
Yeah, I was even all my teachers just tried that.
But yeah, no, and CS, I've been doing it for 25 years. It's an amazing career. It pays well. You can always find jobs. Even when it sucks, it doesn't suck. Even in like 2001 to 2003, where the first time that it sucked, you still get jobs with no problem. 2008, that kind of, it never even sucked. Everybody else was in recession and we were still getting jobs as programmers. Sometimes like you get more money or less money or something like that, but you can always get a decent job. So it's been a very, very good career in that sense. Plus it's a heck of a lot of fun. You get, besides playing with technology, which should be, right, if you like playing with technology, right? I mean, programming is like, oh, they just, right, give me a freaking playground, right? I mean, that's what could be more fun? You also get to fairly easily change domains and have fun all over again. Because you're gonna really understand the business domain, right? And so I worked for 2 years at Microsoft. We were doing digital advertising. So I was learning all the Microsoft technology, but also this idea of digital ads, right? And what does the problem actually look like? And how do I go from there to math and that kind of stuff? Now I'm working for an e-commerce company. So websites, e-commerce, that stuff, customer service, and also we actually do stuff on the warehouse. So it's like, oh, warehouse and operations research and all of that stuff, right, becomes a lot of fun. I haven't gotten bored yet. And if I get bored in 5 or 10 years, I can go work using the same skills. I'm still a programmer in a way, but I can go work at a hospital and do healthcare, and that'll probably keep me entertained for 10 more years. So that makes it a really cool career. Anyway, loops. Get our blinders on. We saw recursion, and recursion is really, really cool, right? But we also are going to talk about loops. Loops are not on the midterm, but I couldn't make stuff work since the midterm is on Wednesday. On Monday, we'll kind of do a sample midterm and go over that stuff. The material is there, but we'll kind of do it on Monday to get you prepared. And then today I'm going to cover loops. The assignment is not due until next Sunday. But when you give instructions in English, we also tend to use loops. Probably not the exact same format, right? This is kind of a very awkward construction in English, but it's inspired by English, right? So you can say stuff, right? Like if you're telling your kid how to pick up the room, it's like, well, pick up one thing, right? And keep picking things up until the room is clean, right? We tend to say those kinds of things to process, right? You keep doing this, right? In programming, we use while, so you say you keep doing this while this condition is true. What is a condition?
If n is equal to 3.
So what kinds of things are conditions? They are expressions, right? That yield what kind of stuff? What goes inside an if statement? Booleans, right? It's any kind of thing that yields a Boolean, right? All the stuff that we saw with Booleans, all the stuff that we saw with if statements, right, is the same thing that goes in there. Except that now we have the condition, and then we have the body of the loop. And that will keep being done, right, while the condition is still true. Notice that just like in recursion, you need to change the parameters to the recursive call. In the loop, you need to somehow change the condition. If not, the next time you go look at it, it's going to be the same result. And so you're going to end up in an infinite loop. Right? We have three kinds of loops. We have the do-while loop. Let me cover it first, because I never use it. It starts with the keyword do, then you put the body inside braces. Just like with the if, you don't really need braces, but you should put them there. Right? If you don't put them, then only one statement is the body of the loop. Right? And then you put the keyword while, parentheses. Parentheses are needed, they are part of the syntax. You specify the condition, which is anything, any expression that yields a Boolean, and then a semicolon. And that semicolon is part of the syntax. And this will keep going, right, while this condition is true. A do-while always executes once. Should first, ask questions later. Probably not a good thing to do, but that's what it does, right? So, for example, we can have a functional read and sum that will read from a scanner and add up all the numbers, right? And we use 0 as the thingy, terminator, right? When you do 0, I will stop reading. And so we will do in sum equals 0, right? Start our sum at 0, declare our input, and do a bunch of times, right? At least once, int print, please enter a number, 0 to stop. Read a number from the scanner, add it, and we keep going while the input is different than 0. Are we changing our condition inside the loop? Yes, we are changing the value of input, so potentially we are changing input different than 0, right? So eventually the user will enter 0 and this will terminate. Does that make sense? Do while always executes at least once. Most people use while loops. I tend to, yeah, like I can't remember the last time that I used to do while. Normally we have whiles. You do while condition, and then you put the body of the loop. You don't have a do. The semicolon is not part of the syntax, but the parentheses are. The braces are not, but they should be. You should always put the braces, right? Important thing, this is ask first, shoot later, right? So you may or may not shoot. In this case, you check the condition first. And so you may not execute the body of the loop at all. Does that make sense? Cool. Now, what happens if you want to do it once? You would either copy the body of the loop above, or set up the condition cheating, right? Initialize your variable so that you go through once. Most of the time, this works, and most of the time we end up doing the copying the body of the loop because you don't want the exact same thing. You want almost the same thing, right? Like imagine that we are doing reading until the user enters yes or no, right? Well, the first one may be, please give me a value, and then the second one is, no, it has to be yes or no, right? So it's actually not quite the same thing. Oops. I lied to you. Wow. Let's go to it. This one's still doing a do while. It's not a great example of a while loop. Now let's do the same thing with a while loop. A very simple way, right? Would be to do this, copy the body of the loop, and then move my condition to the beginning. Does this make sense? If I'm doing exactly this, I probably want to do while, right? But normally, I would end up doing something like this, right? And now, it's not exactly the same thing above and below, so it makes sense to have it separate, right? This kind of sucks because this is almost the same as this. On the other hand, it's not quite the same, so. Does that make sense?
So we have the sum plus equals input. Is that like incrementing it, or
Yes. This is equivalent to what?
sum plus one? Or
Sum equals sum plus input. It's just prettier syntax for that.
Okay.
Let's call thing, or am I running? I'm running probably the wrong thing. This is what I wanted. 1, 2, 3, 0, 6. Woohoo! Right? Now let's do it with the while to verify that we did the same thing. Oops. Is this cool or what? You did something very similar with recursion, right? Which one is simpler to understand? Good. Your brain hasn't been polluted. Many times people see loops first and do a lot more of them, so they think recursion is hard and advanced and weird. Actually, it's about as good or as bad, right? The other loops end up being more useful, but the for each loop is actually really cool. And then we stop using it too. But does this idea make sense? Both loops, right? Imagine that we want to count and print. Of course. God. Right? So this would allow us to print, right? All the numbers from say 1 to 10 and use system.out. Does this make sense? Yes? This kind of loop ends up being super common. We are doing some initialization. We are setting up our variables, right? We have our condition, then we have the body of the loop, and then we have other stuff that's kind of the change of those conditions. Does that make sense? And those are kind of distinct things. So the guys who created C said this pattern is very obvious, so let's create a loop that just puts this in with a nicer syntax. So that is the for loop. First you put the initialization, then you put the condition, then you put the increment part, and that leaves the true body of the loop easy to see. It makes the intent of the code more clear. Does that make sense? Other than that, it's exactly the same thing as a while loop. Almost exactly the same thing as a while loop. A tiny difference is that the scope of this variable is available, right? This variable is available outside the loop, when you are doing this variable is only available inside the loop and doesn't pollute your namespace outside. But other than that, it is just a different way of writing a while loop.
So that one is almost look like recursion.
Yeah, it makes the loop clear, but it's not. There's not really recursion. You're not calling the same function, but yeah, it is kind of elegant. Actually, most programmers use for loops for everything, which is kind of dumb, but. With the for loop, you can leave anything out. So if you don't want initialization, right, you can just leave it out. You have to put the semicolon to say there's nothing here, right? But you can leave stuff out. So you could actually just do this, which would be really dumb, but you can. And that would be equivalent. Does that make sense? Don't do it, but you can. In a way, all you need to know is the for loop, right? And you can convert everything into a for loop. And many programmers do. I don't think you should, but you can. In fact, all three loops are equivalent, right? You could write everything with a do while, or everything with a while, or everything with a for.
Is it just lazy, or is it
It is laziness, yes.
we're just trying to solve everything with a solution?
Do whiles tend to almost never appear, because normally you want to check first, right? And if you end up repeating the body of the loop, you end up doing it like this, so it's not exactly the same. So I tend to never use a do while. For versus while, when I'm trying to do a while, I'll write while, but many people just write for loops. Basically, the guys who invented C really like for loops, because right, it's a very good hammer, and that's all you need. And so that style of programming kind of propagated throughout.
So would you use like a do while if you wanted to check maybe a password, make sure that it was correct before returning like this is invalid? I'm trying to think why you want to run something for.
Well, if you think about our example for reading, right?
Yeah.
This makes some sense with a do while, right? Because I want to ask for at least one number. So that one would be an example where do while would be okay, not horrible. Many times you end up having if statements inside your loops to modify, right? Yeah, only this piece gets executed, so it starts becoming kind of ugly regardless. This idea makes sense. All the loops make sense. Go make sure that I didn't skip stuff.
So that one says while I is greater than equal to 2.
That was wrong because I changed it to low and high.
Sorry, I wasn't paying attention.
It was from and to.
Oh yeah.
At some point in time I changed it to low and high in half the places. I'll go verify. I've read these notes 5 times, but the problem is that after you do that, you stop reading them and you never see that stuff. It is good that I'm rubber ducking it with you guys. Pair programming works. Paired note writing works. This is the for loop. There is a couple of things. I'm horrible at writing this stuff, but the original idea, right? Before loops were common, people had go to, so it was just go to this instruction and keep going from assume that you're in a loop. And it was very easy to confuse yourself. And so Dijkstra came up with this go-to statement considered harmful and said, you should only have these particular patterns, right? And only a few patterns and let you do that stuff. And that's okay. Now, we also came up with, well, where should you get out of the loop, right? In a do-while, where do you get out of the loop? At the end, right? In a while loop, where do you get out of the loop? At the beginning. Sometimes you want to get out in the middle, right? There is a keyword that lets you get out in the middle of the loop. That is the break keyword. Break gets you out of the loop. Normally, you don't want to write a break by itself. You have an if statement, and if some condition is true, then you break out. Right? So actually, this is how I tend to write reading loops. I do while true, right? And that's, I'm never gonna get out of the loop except with a break, right? And in here, inside the loop, I have this if input equals -1, break. That way, I don't process an invalid input, right? For the other stuff, it was okay, because, well, 0, if I add it, it doesn't matter, right? But if my sentinel, my terminator was different than 0, then I need to make sure that I don't add it, right? And so in this case, this allows me to just get out of there before adding, before processing that input. Does that idea make sense? Rather than have a condition and an if statement so that I don't do certain things. Now, a standard dumb thing is to write this instead of while true. In a for loop, I can skip everything, including the actual condition. So that will be done forever. It's actually, cute programmers tend to read it as forever instead of for semicolon, semicolon. Just, oh, that's a cute pun. I'm smart. It works, people write it. I find while true easier to understand, but there is another keyword called continue that doesn't get you out of the loop, but it skips the rest of the loop. Just skips one piece. Does that make sense? So it just skips until the condition again and then goes checks and maybe goes do it again. I never use continue. Some people do, sometimes you will see it, but it's fairly uncommon. Break is not terribly uncommon, continue is.
So how is the code different?
Let's do stuff with break and then let's do stuff with continue. Let's do this one, right? Let's go do it. Let me do, okay, imagine that you don't have break, right? But now our terminator is -1, not 0, right? So how could we write this with a while loop? Please enter a number, input, while input different than -1. Would this work? Yes-ish. What's the problem?
Negative 2 shouldn't be
I added this guy, right? So my sum is gonna be off by 1, right? I could undo it, but so do something like return sum plus 1 here or something like that, right? But ideally, what I should be doing is if input greater than or equal or different than -1, do this, right? Does this make sense? That way I never added that extra thing. In this, it was okay because it was 0. But in here, where it's not 0, right, I need to be more careful. Does that idea make sense? This is what it would look like with a while loop. I have this horrible thing. I'm repeating the same condition and I need to be careful, right? Rather than do this, I can omit this condition and in here do break. I'm getting out in the middle of the loop. Does this make sense?
If it's that case.
Sorry?
If it's that case.
Yes.
Yeah.
And so I skip this thing, I never do it. Right? Now imagine that I'm doing get our trusty is even. So imagine that we only want to sum the even numbers. Still, -1 is to stop, right? Oh, wait, and if I'm doing it with a while true, then I don't need this first one, right? If it's, oh, yes. Oh, thank you. Let me actually at least. Let me test it, because chances are that I screwed up somewhere else, right? Please enter number -1 to stop. 1, 2, 0, -1 should return 3, right? Now, only even ones, right? If I run it, it's gonna be wrong because I just did that, right? So 1, oops, 2, -1. I got 3, which is bad, right? Because I added the 1. So let's go change it. How can I make read and sum even to only add the even numbers?
Yeah, you're gonna break on if you're gonna change it to.
Right? Well, this is still okay, right? If it's -1, I'm gonna break. But now, what's the problem? If the number was 1, what's the problem? That I still did this, and I don't want to do it, right? So what do I want to do? I should only do this when what happens?
When
Input
even
doesn't
or-
equal. If they're
When input is even,
yeah.
right? Let's just equal 1, maybe 5 or 7, right? So how can I do that?
If input match
I created my is even function. Does this make sense? I only do it if it's even. Right? So now if I were to run it, I get 2. This makes sense. Questions? It's all beautiful. No questions. I could alternatively write it like this.
So it'll be for us.
If it's not even, continue. Skip the rest of the loop and go back to checking the condition. Skip until the end of the loop and then go back and, right? Pass go, collect 200. It is absolutely dumb, but we are doing super simple stuff. Cool. This makes sense? No questions? It's a good idea to know what continue does. I cannot recall an instance where I actually use continue. Like, I'll come up with these contrived examples because you can always torture a problem until you make it fit whatever you want, but it's not. But it's not natural. It's weird. So let's do some more examples. Power. What makes sense for power? Besides recursion, of course.
keep multiplying it by itself.
But
as
which
many
kind of
times.
loop? Which kind of loop would it make sense? Would make sense to have? For loop, right? Because we are just counting the number of times that we multiply, right?
Yeah, for 4 decimal times.
So int pow equals 1, int I equals 0, and this is what we end up doing, right? I less than exponent plus plus I. Pow times equals base. Yeah. we tend to do this kind of stuff all the time, right? Does this make sense? Let's do and I'm gonna start doing more examples, and hopefully we won't hit once I turn the assignment.
We won't tell.
Yeah, if it happens, then it happens. I usually give you enough examples in the assignment that if it happens, then it happens. And I trust you guys to always kind of self-monitor, right? And so if you need more examples, what do you do? Come up with more examples, right? Go look at Coding Back and do more examples, right? Find more examples and do them until this becomes second nature. It sort of sucks, but this is exactly that kind of class, right? It's drop and give me 20. You need to do a million of these until your fingers type this stuff without thinking. Let's do this. Int digit to number car C. How do we transform a digit, right, a character 0 to the number 0, or a character 1 to the number 1, that kind of stuff? What is the ASCII, right? What does the computer do? They just agreed, right, and said, okay, 60 is the number 0, right, and 61 is the character 1, 62 is the character 2, right? Don't know whether 60 is 0, I don't remember. Maybe 64, I don't remember that stuff. So what can we do? Subtract the character 0 from it, right? So if this was 60, right, then as long as they do 0, 1, 2, 3 in order, right, this would work. Does that make sense? We could also do a case statement or something like that. But this trick usually works because the ASCII code goes like that. The numbers go in order. The digits go in order. Does this idea make sense? Yes? We can actually go figure out what was that thing by either Googling the ASCII code or by printing int 0, and that will print 0 as an int, which is 48. It's 30 in hex. But it doesn't terribly matter because it is whatever the code is for 0. Does that make sense? So if we go look at 1, it's going to be 49, and 6 is going to be what?
Five.
48 plus 6, 54, right? Because 48 was 0. Does that make sense? Just subtract 48, right? Or add 48. So in this case, we're going to be subtracting 48. But this way, we don't need to memorize whether it was 48 or 60 or whatever the code for the character 0 is. It's kind of weird to treat characters as ints, right? But so how can we add up all the digits of a string that supposedly contains only numbers? We could do here something like this. If c less than 0 or c greater than 9, return 0. Just send me a letter, I'll count it as 0. So how can I, if you give me a string that contains only digits, right, how can I find all those things? How can I go over a string, over all the elements of a string? What methods do I have on a string? Substring contains, what other methods do I have? Do I have a method for, yeah, char at, right? And length, right? So I can do a for loop, go for int I equals 0, I less than number dot length plus I, right? And actually do int sum equals 0, sum plus equals or number dot char at I. Would this work? We call it digits. How about this? Would this work? Do the refactoring? Now it's gonna be weirdly colored forever. Oh well. It's signaling that it could do the refactoring, but I don't know how to take it out. Would this work? Not quite, right? We're adding the ASCII code. We need to translate that to the actual value. How do we translate it? Digit number, right? I'm going to return something at the end. Does this make sense? May even work. Static all over. And this would print 55, maybe 45, 45, right? Does this make sense? What other examples would be cool? We don't have many interesting things to iterate over yet. Oh, let's do cool stuff. Factorial, right? How do we do factorial? For loop is basically power, right? Well, let's create our variable. Fuck equals 1. What's our for loop gonna look like? What's our variable name inside a for loop? Our loop variable. By convention, always I. Why? Because if you need to do nested loops, what's the next variable? J. Why? Because. Right? I less than what? Probably cannot start. Let's start at 1. Okay, let's do this. Plus plus I. What do I do? Fuck times equals what? What number do I multiply by?
N times n minus 1.
Well, it's which numbers am I multiplying?
Factorial.
How do I get the factorial? It's
Minus.
1 times 2 times 3 times 4 times 5, right? So in this case, which number am I multiplying?
Factorial minus 1.
This is that would be if I have recursion, right? I don't want to do a recursion. Which one of these numbers, right? If I multiply times n, would that work?
No. N.
Because that would do power, right? What do I need to multiply by? So when I is 1, I multiply by 1, then times 2, times 3, times 4. Does that make sense? Is this correct?
So it's not going to include n.
Ah, you got it. I need to run it to do it. Factorial of 3 is 2. Is that correct?
No.
No. What happened here? What do I need to do?
I is equal to less than or equal to n.
I can actually start at 2. Right? So I really never need to multiply by 1, right? I get 6. Let's do 6 should give me 120. No, 720, sorry. 5 is 120, right? 6 is 720.
What about 1?
Sorry?
1.
Well, what happens if I pass 1 or 0 or minus 237 or minus 123? That's what I actually typed. What's this loop going to do? It initializes to 1, and then what happens here? I initialize I to 2 and check this condition. Is this condition true?
No.
No. Then I'm done and do this. So this would actually return 1. Does that make sense? You don't, it's a while loop, so you don't always end up doing this stuff inside. Cool. Now let's do fun stuff. I'm gonna do Fibonacci sequentially. This is gonna suck. So, what do I do? Right?
You need two initialization.
I need to initialize int prev. The previous is gonna be 1 and previous 2 is 0, right? And my int ans equals, let's call it 0. Yeah. I'm gonna do ans equals prev1 plus prev2, right? Prev. Let me call it Prev or Prev1. What's better? Prev1. Then I'm gonna make Prev1 equals ans, or yeah, Prev2 equals Prev1, and then Prev1 equals ans. Yeah. And this might even work. Does this make some sense? Probably need. Yeah, no, this seems reasonable. Fibonacci of 3 should be 0, 1, 1, 2, 2, right? Fibonacci of 0 is 0, 1 is 1, 2 is 1, 3 is 2, right? So we should get 2, hopefully.
Why is right wiggly line better?
Yeah, we'll see. It will tell us. Yeah, missing return statement. Oh, no returning statement. By the way, notice that it tells you the line number, right? If you're doing the compiler, actually it will print horrible stuff, but with the line number, right? So you would know. Oh, we in trouble. Do this for int I equals 0, I less than 10 plus I. And now we can do these kinds of things, right? And have better ways of testing stuff. We can better debug our code.
How'd you get the arrow
Oh.
to appear?
Oh, this is, sorry?
How'd you get the arrow to appear? What'd you do?
Which error?
The
This arrow? Oh, sorry, my font is messed up, so it does ligatures. Fonts in computers do ligatures for
okay.
2 characters, where 2 characters should look weird.
Okay.
And I, at some point in time, installed a font that has ligatures, and now it infected my system. But it's pretty. I don't know how to take it out anymore. I need to go Google that stuff and undo it. But I'm too lazy to. It also does stuff like this. Which is pretty. Ha! My fonts are prettier than yours. How did we get 2? Almost. It's almost right. Like, I feel tempted to just do a special case.
Those are evil.
Yeah. Oh. Let's see. 0, 1. We are skipping the 1, right? Yeah. No, we cannot do a special case. No, we are just doing an extra 1, right? See what happens if we do. Oh, we are already doing this. Ah.
I think it has to do where it's, you said the Prev 2 was Prev 1, and then is it where it's adding Prev 1 to Prev 2 above it? So would it, I don't know. Seems like he's kind of stuck in the start spot.
Prev 2. I am an idiot.
Should
Yeah,
be,
no.
Prov 1 should be 0 and Prov 2 should be 1.
Thank you. No, right? No, that can't be. Oh, I'm confusing my 2 and my 1. Can I do this? Would this work? No.
It should work that we change the I equals to 0. And minus 1.
Oh, 0, 2, and minus 1?
Yeah.
No, no, we got it. We got it. This is it. Right?
But we didn't change anything.
0, 1, 1, 2, 3, 5, 8. I was starting at 1 rather than a 0. I am an idiot. For no particular reason, I was starting at 1, and that was the problem. In my for loop.
Well, no, so before you had 0 originally, but you had Prev 1 is 1 and Prev 2 is 0. So when you fix that, fix
Oh,
the problem, we were playing around with it earlier, and we changed the I to start with 1 instead of 0. So
Oh, so that actually, God, but that is horrible. Proof 1 is 0 and proof 2 is 1. It is horrible, but it works.
don't touch
Yeah, don't touch it ever again. Just make sure that you write good unit tests and don't touch it. Yeah, I'm not happy, but it works. That's an incredibly cool ability of working. So we are gonna leave it like that and move on to another example.
Never speak of it again.
Sorry?
Let's never speak of it again.
Yeah. Yeah. Cool. So you know all there is to know about loops. Right? Just so you know, sometimes, and we'll do some stuff eventually that's complicated enough, you may need to nest loops. So you do a loop inside a loop, and so you may end up doing things tons and tons of times, right? We have 5 minutes. We can do stuff, right? So we can do let's do this. Print a number of stars, right? So we can do for in a line, right? This is a star. And at the end we do out.print. So we can do print stars. Oh, hate you thingy, you have to be static, okay. See if it works. prints 5 stars, right? Seems fairly reasonable. Now we can do this. This will print a beautiful triangle. Ta-da! Isn't this cool? I seldom do nested loops because I end up writing my code like this. It doesn't look like a nested loop because I'm just calling another function.
So this not like a little DOS to daily kind of like have those kind of like splash pages or whatever with all the.
Yeah. This is one way of doing those kinds of things. You either do that or you program it to generate that stuff, like read it from a file or something, but yeah. End up writing generators for every letter and make them go through the screen and things like that. Isn't that cool and painful? Cool. Actually not that painful for like geometric figures, right? You should be able to do those things. Okay. You could also write this with an actual nested loop, but I seldom do. Questions, comments, complaints, whines, beers? Cool. Then I will see you guys on Monday when I will do a sample midterm, right? And we'll go over the sample midterm and that kind of stuff. Then I'll see you guys on Wednesday when we'll actually have the midterm. Reminder, we don't have an assignment due this Sunday. We moved it to the next Sunday. Also, I have been very lenient with due dates, but we can't be lenient anymore. So on Monday, we'll also release solutions or sample solutions to all the assignments. And after that, I will not take any assignments, right? So if you didn't do any of the first 4 assignments, make sure that you do them by Monday. Cool. Sorry?
When are you gonna grade assignment?
4? As soon as I can,
Oh,
but
yeah.
I'm behind. I have been super busy and that's what's gonna happen regardless, but I am trying. I'm now only, I think 2 days behind. I think as of this morning, the only GitLab showed me 2 days ago. It's still like 30 assignments that I still have to go through, but
You're usually fast, that's why.
I am usually fast, yeah, but yeah, I'm teaching the algorithms class, and I have given you guys preference on grading because you need a lot more of the fast feedback, but I needed to spend time there too. Life sucks sometimes. I'm sure you